Hi everyone, Mr. Neighbor here, and today we're going to talk about how to graph proportional relationships. Or more specifically, if we look at a graph, is that a proportional relationship? Just like we looked at tables to see if they're a proportional relationship, we can look at graphs to see if they are a proportional relationship as well. So first, let's just go over some graphing basics that we already had. Down here we have the x-axis because it runs horizontally. Over here, we have the y-axis because it runs vertically. Here is the origin because that's where the graph originates. And whenever we graph, we always graph alphabetically. The coordinate is x and then y. So here we have 0, 10. So I go over 0 horizontally, which would be right here. And then I go up 10, which would be up to here. Okay. Next is 1, 8, so go over 1, up 8. Next is 2, 6, so over to 2, up to 6. Then 3, 4, over 3, up 4. And then lastly, 4, 2, over 4, up 2. Okay. If I were to look at this, it would create a line, a straight line. I could put my ruler down and create a straight line right there. I want to know, is that proportional or not? So we don't know if it's proportional just by looking at the graph yet. So we have to actually look at a table. And we're going to look at an XY table. So we're going to write down all the x coordinates, which remember are the first ones. So 0, 1, 2, 3, and 4. Next, we're going to write down the y coordinates, which are the second ones. So 10, 8, 6, 4, and 2. Now we have to look to see, is it proportional? So when I take y divided by x, will that come out to be the same proportion every single time? Will it have a COP, a constant of proportionality? So 10 divided by 0, well, that's not a very good one because you can't divide by 0. So let's kind of move away from that. That we call undefined. Let's try 8 divided by 1 instead. Actually, that's simplified, so I can't do anything about it. 6 divided by 2. That would be 3 over 1. And right away, we see these do not match. So this does not have a constant of proportionality. This is not a proportional relationship. Proportional. Okay, so it's not proportional. So we're going to look at this graph visually after we do another problem and then kind of compare and contrast. So let's scroll down and look at another problem. Here we have an example of a graph that's already been plotted for us, but we don't have the coordinates. So let's make a table of the coordinates. All right, so let's do the same thing, an XY table. Before we were working with things that were not X and Y, because we were talking about actual quantities, cups of rice to number of people, number of spring rolls to number of people. These don't have labels. The label would appear right here, but they don't have labels, so we just have to go with X and Y. That's the only thing we can do. So let's look at this one. Remember, coordinates are always listed as X comma Y. So X, we go over 2. Oops, but it's not 2. 2's right here. We go over 2 lines. So what are we actually counting by? Well, it looks like every single 2 lines is 1. So it looks like we're counting by steps of a half. So every single tick mark here is actually a half. And this is 1. And that's 1.5 or 3 over 2. So the very first number I should write down for X is 1. This looks like it's climbing by 1, but it really, every 2 is 10. So that means this should be the number 5. So we're counting by steps of 5 on the Y. not the same as the x, and that's perfectly fine. It's whatever fits your situation. Then we have over 2 up 10, over 3 up 15, over 4 up 20, 5, 25, and 6, 30. So now let's look at top. Let's look and see if y divided by x, the proportion is always going to be the same. So 5 divided by 1, that's already simplified. 10 divided by 2 comes out to be 5 over 1. 15 over 3, yep, that comes out to be 5 over 1. 20 over 4. And if we kind of jump ahead, all of these are going to simplify to 5 over 1, every single one of them. This does have a COP. It does have a constant of proportionality. And that COP is 5 over 1. So this is a proportional relationship, which means we have an example of a proportional. Sorry about that. We do have a proportional relationship right here, and we have a not proportional relationship. So let's compare the two graphs. So this graph, it looks like it starts in the origin, is a straight line, and it always increases by the same amount. This graph doesn't start in the origin, so that's a problem. It does decrease by the same amount, but because it doesn't start in the origin, it's not going to be proportional. So here are some key characteristics to make a proportional graph. Number one, it must start in the origin. Number two, it must be a straight line, not a curved line. And yes, lines can be curved. Must be a straight, line. And three, this kind of goes along with number two. It must have, actually, no, we don't need to write that. Well, I was going to say must have a COP, but that COP comes in with the straight line part. So if it starts in the origin and is a straight line, you will have a proportional graph. So let me make some graphs and let's decide if they're proportional or not. So let's say I have this and I have a graph that's like that. Assuming this line is straight, is that proportional? No, because it doesn't start in the origin. Let's say something like this. And it goes like that. That would be no, because it's not a straight line. It's a curved line. Also not proportional. Let's say we have something like this. It barely gets off the ground. If that is a straight line, and it did start in the origin, it would be proportional. You look at a graph that looks like this. That would not be proportional because it doesn't start in the origin. So the key points are right here. If a graph is proportional, it must start in the origin and it must be a straight line. Then if you look at the table, you will see this COP come out. You will see that happen. If it's not proportional, when you do your table, you won't find a COP. It will be something like we had up here where it's two different proportions. So that's how you find a proportional relationship from a graph.